In chapter 8 for 8th grade, chapter 5, 8th grade. This is lessons 1 through 4. So just a quick overview of all the lessons. Lesson 1 is lines. We have a quiz tomorrow, so that's why I'm doing this. Okay, so in the lines section, we talk about when you have two parallel lines cut by a transversal. This line right here is called a transversal. And these two are going to be parallel lines. So they never will touch. They're going to keep going forever and they're never going to touch. That's what these little symbols mean. So two parallel lines and then one line that goes through them both. This is called a transversal. Okay, so when we have a transversal and two parallel lines, the angles we know some of them are going to be equal to each other. So for example, we talked about how angle 2, angle 1, angle 7, and angle 8 are called exterior angles because they are outside of the two parallel lines. And we also talked about the inside ones, 3, 4, 5, and 6 are called interior angles. Okay, then we have a special type of interior angles, and the ones that are on opposite sides of the transversal, so 4 and 6. For example, also 3 and 5. These are called alternate interior angles. So for example, angle 4 and angle 6 are alternate interior. Also 3 and 5 are alternate interior angles. Then you have the other ones, which are the alternate exterior. So that would be, for example, 1 and 7. They're on alternate or opposite sides of the transversal, and they're outside of the two parallel lines. So these two are alternate exterior angles. Okay, and then also 8 and 2 then would be alternate exterior. The last set is going to be called corresponding angles, and I'm not sure what color to do for these. So corresponding angles would be in the same position. So for example, 1 and 5 are in the same position on the two parallel lines. The 5 is up at the top left-hand corner, and the 1 is also the top left-hand corner. So these are called corresponding angles. I'm going to go ahead and write that, corresponding angles. And I'm going to put a star by it because I'm going to star them purple. So for example, number 1 and number 5 are corresponding angles. Number 2 and number 6 are corresponding. 7 and 3, 8 and 4. These are corresponding angles. Okay, so when you have corresponding angles, they are equal. So if angle 1 is 140 degrees, then angle 5 will also be 140 degrees. Also, the alternate exterior and alternate interior angles are equal. So if I know that angle 1 is, like I said, 140, then I also know that angle 7 is 140. So these two would be the same. They're alternate exterior. And then also 6 and 4 would be equal to each other because they're alternate interior. Okay. You also know that because this is a straight line, if you add 2 and 3 together, those would give you 180 degrees. So you can do that with several problems. You know that if it's a straight line, the two angles form a straight line, then they equal 180 degrees. So you can take 180 minus one of them to get the other side or the other angle. Okay, we're skipping lesson 2. That's basically what we did in this lesson. There were some ones that gave you pictures and you had to find the angles, but if you know all of these and you know which ones are equal to each other and you also know the 180 degrees, then you can find any of the angles that are cut by the transversal. We're skipping lesson 2 because that's proofs and it's not our most important lesson, so we all skipped that one. In lesson 3, this is angles of triangles. So the most important thing that we learned in lesson 3 is that the sum of the inside or interior angles of a triangle is 180. Remember, sum means when we add all the angles together, so this angle, this angle, this angle, we would get 180. And so we did several problems with this. Let me just write one and I will do that for an example. So let's do, if I have this triangle here with a ray off to the side, and it says that this one is 134 degrees, and this one over here is, it says 22 degrees, and we want to find x. In order to find x, we would have to know what this angle is, because this one plus this one plus this one equals 180. So I'm going to take 180 minus the 134 because this angle is equal to this one, this one and this one added together equals 180. So I have 180 minus 134. Which would give me 46. So I know that this angle is 46 degrees. And because I know this one is 46 and this one is 22, then I can do 46 plus 22 and then subtract this amount from 180 because my total is 180. So 180 minus 68 would give me 112. For this third angle. Okay, I did not draw this very well because this is supposed to be an obtuse angle and this one's supposed to be smaller, but in general, this is how you would solve the problem. So 120 degrees is our x value. Okay, and then in lesson 4, we talked about polygons and angles. So we made a table of the different polygon shapes. Poly is many sides. So a triangle has 3 sides, quadrilateral is 4, pentagon, hexagon. This is a heptagon. I said septagon in class today, but it's actually heptagon, sorry. So heptagon, octagon, nonagon, and decagon. And then the sum of their interior angles is going to be equal to 180 times the number of sides, and then we subtract 360 from that. So for example, a triangle has 3 sides, it has 180 degrees for the inside angles. If we add another 180, we would get to 360 for a 4-sided polygon. 5-sided has 540. You do not have to memorize these if you can remember 180 times the number of sides and then subtract 360 from that. Okay, a regular polygon we talked about was all sides are equal and all of the angles are also equal. So, for example, if I have a pentagon and I know that it is a regular pentagon, I can find one of the inside angles because the total of the inside angles is going to be 540. And if they're all equal, then I can do 540 divided by the 5 angles. So 540 divided by 5 will give me 108 for this angle. Now you can only do this if it's a regular polygon. So in this case, it's a regular pentagon. I could say a regular nonagon or a regular decagon. That means all the angles inside would be equal and all the side lengths are also equal. So for a regular pentagon, each angle is 108 degrees. And I can also do the outside angles because we know the exterior angles of a polygon equal 360. So 360 is the total for the outside angles. These are inside, interior. Exterior would be outside of the polygon. So I've labeled some here, and I know that my total is always going to be 360. So the only thing is, I don't know what this outside angle is yet, so I need to find it. This is 80. Actually, this one is much easier than I made it. So let me, if I didn't know, let's say I didn't know what this one is. Okay, if I know that this one is 80, then I know that this one is 100. Because 80 plus 100 equals this straight line here. Okay, and then I also know that all of the outside angles added together equals 360. So if I do 50 plus 70 plus 80 plus 100, so 70 plus 50 plus 80 plus 100, I'm going to get 300. And I know that all of them together equals 360. So this one would equal 60 degrees. Okay, and that's basically all we did in lessons 1 through 4. We'll have a quiz tomorrow. And I want you to take the quiz that I'm going to post on Edmodo if I can figure out how to do that. Thanks.